Welcome to the lecture 2 of problem solving and computer programming course. So, in this course, we will continue our discussion from the last class regarding the computer and its components. So, we'll continue with data or code today, right? So, data is nothing but the fact or figure or the things whatever you are collecting from various sources that we call as a data. So as a simple example, I will tell you the data is nothing but a student's roll number is a data, a student's name is data, or you can say a student is securing whatsoever marks in this PSCP subject is a data, right? So for example, 101 is the student roll name, student name is XYZ, his mark is 20 out of, let's say, 30, right? Similarly, roll number 102, his name is, let's say, TQR, and marks is, let's say, 25, right? So this is a data about a set of students, right? So next is while you are collecting the data, the next step is to process this data. For example, suppose after collecting the data of a student strength of 70 or a student batch of 70 people, what I will tell you, you find the average mark, right? Average mark about that particular course, average marks in the course of PSCP. Then what you will do? You will add all the marks of each and every individual student. Then you will divide it by the total number of students, that is, let's say, 70, right? Total 70 students marks you will add and finally divide by 70. That will give you the overall summary of the data. So you are processing the data in order to get the information, right? So first of all, we will see if such a data is there, like you can say here, a character A, capital A is also a data, right? But computer do not understand what is capital A. Computer only understand two things, that is the value is 0 or 1. So what you need? You need to convert this A to a sequence of zeros and one such that computer will understand you want to give A as an input. You can give A as an input from your keyboard, but it should be converted to in some binary form. Binary form means either 0 or 1. So the data may be simple as like this, or the data may be complex like this, right? So all the data finally we need to convert into 0 to 1 in order to represent or in order to make it understandable by a computer system, right? So you can see here, if you want to represent A, capital A, we have a code. We have a code. There are two types of code we are using, okay? Representation code, that is called as ASCII. That is American Standard Code for Information Interchange. Another code is there that is called as EBCDIC. Okay, that is Extended Binary Coded Decimal. Okay, extended binary coded decimal. Yes. First code is called as American Standard Code for Information Interchange. Second code is your EBCDIC code, right? For information, EBCDIC. So you check the full form of EBCDIC, Extended Binary Code for Information Change or something like that, right? So these two codes are used, right? So if you go for ASCII code length is 7-bit, right? But if you go for EBCDIC code, its length is 8-bit general, okay? So suppose I want to represent A, the capital letter A.
Sir.
Okay.
Sir.
Yes. Yes, please tell me.
Sir, please record this class. Someone has issue with network. He unable to join this class.
I have also started recording, right?
Yes, sir. Thank
you. So Suppose I want to represent A into the computer systems, then either I have to represent A in ASCII code or in the ABCD code. For the simplicity, what we are representing? We are representing each and every alphabet in the form of 8-bit. Right? You can see 1, 2, 3, 4, 5, 6, 7, 8. 8-bit is required to represent the data. Right? Or any character or anything you want to represent, you have to represent in a sequence of 8-bit. And the last bit is called as your LSB, that is the lowest significant bit, and this one is called MSB, that is most significant bit, right? And the position of the last digit is nothing but 0. Next is 1. Next is first one is 0. 0 is nothing but, if you represent, let me write here so that it is more clear. 0, 1, 0, 0, 0, 0, 0, 1. So the last bit is nothing but your 2 to the power 0, right? That is equal to 1. Okay, that is the 0th bit. This is the first bit, second bit, third bit, fourth bit, fifth bit, sixth bit, seventh bit, right? That is 2 to the power 0, 1. Second bit is nothing but 2 to the power 1 is equal to 2. Next one is 2 to the power 2 is equal to, let's say, 4. Here 2 to the power 3, that is 8. Similarly, this is 2 to the power 4, okay, 2 to the power 5, 2 to the power 6, and 2 to the power 7. Right? Like that it is processed. Right? 0, 1, 2, 3, 4, 5, 6, 7. Right? So if you see, ASCII code of A, okay, is nothing but 65. So you have to convert this A into in a sequence of 0 and 1. How you are going to convert? You have to represent these according to their positions, right? Like I told you, this position is 1 means the value is 1. So here you can say the value is 1. This position is 1 means this is 2 to the power 6. 2 to the power 6 is how much? You have to multiply 2 6 times. So if you multiply 2 66 times, you are going to get 64. So the bit which is used, that is represented by 1. The bit which is not used, that is represented by 0. Like you can see, in this case, these two bits are only used. And what is the value of this bit? This is nothing but 2 to the power 0. This is 1, this is 2, this is 3, this is 4, this is 5, this is 2 to the power 6. So the bit which is used, you will represent by 1. The bit which is not used, that you will represent by 0. So this is 2 to the power 6 means this is 64, and this is 2 to the power 0 means 1. So the value of this sequence of code is 60. Right. So A is nothing but represented in the form of 01000001 because its ASCII value is 65. That's why in the next slide they mentioned that 65 also looks like this one. So when you press a computer character A, okay, that is capital A, then it is converted to 01000001 so that computer will understand that the user is going to provide a data that is capital A. Right? Similarly, for each and every character, the ASCII code is there. So as a assignment, what you can do, you can search in the Google about ASCII code, means their mapping. 0 indicates what, 1 indicates what, 2 indicates what. Similarly, you go through the EBCDIC code also and see the coding format, right? Now, suppose user want to give A as an input. I told you computer is accepting input and producing the output by performing some kind of processing here, right? Some kind of processing is done to convert the input to output. So A may be an instruction, right? Suppose I will tell enter a character, right? I want to receive a particular character in a program. So what you will input? You may input A, you may input B, you may input C up to Z. Any character, one character you have to input. So suppose a user input A, okay, that A is a input which is given as an input to the system and it is converting A into 01000001. Okay. Now the question arises, how does the computer know the meaning of this one? So there should be a coding. Like last class I told you, suppose you do not know X language, okay? So somebody should tell something, okay, to convert your language to that language or that language to your language so that you can understand. Suppose you will tell what is the meaning of what, right, in that language. Somebody will tell what is like this. Okay. So you will map your language with their language, then only you can understand. Like we understand A, computer understands 01000001, right? This value computer understands. So there should be a mapping. If the mapping is available, whenever you are pressing A, computer will say no, user is pressing A means it is mapped with 01000001. Okay. So like that, we are giving several instructions to the computer system. Not only a single instruction, a lot of instructions we are giving, or a sequence of instructions we are giving. For example, I will tell what is your hometown. Suppose you will say Warangal. So you are entering a several letter, right? So W is representing 8-bit, A is represented 8-bit, R is represented 8-bit. Like that, you can see if it is a 8 letter, then 8 cross 8, 64-bit you are generating by giving a small input that is nothing but a hometown of a particular person. So this interpretation, how computer is interpreting, it is interpreting based upon the current instruction. So lot of instructions you can give, right? Suppose I will take all the students one by one, you enter your, let's say, hometown, right? So people will enter, somebody will enter Warangal, somebody will enter Hyderabad, somebody will write Kurnool, something like that. So a sequence of instructions you are doing, but computer will execute one by one. Okay, based upon its capacity, it is going to execute one by one instructions. So the instruction which is referred by the computer currently is defined as a current instruction, right? That is the current instruction that the computer is performing in order to get a particular solution, right? After that instruction is over, it is again, and it will execute another instruction. Like that, it is going to process. But why should we care of this thing? Somebody will say that if I am pressing A, computer is understanding this one. Why should I know this one? In order to go for the memory organization, in order to see how these things are available in the memory, computer memory, how these values are stored in the memory, you have to have an idea that how it is converting from one format to another format. So here you can see the programmers rarely need to concern with this problem. This is already there. Your keyboard is already up like this, so that whenever you are pressing, you need not bother about these binary codes, it will be automatically built. But as a computer science student, you should understand how the computer is interpreting the thing. But as an end user, suppose you are giving this product, you have developed a software, you are giving to some X company. That X company user, they did not aware of this particular system. They want simply to use the system without going for this particular complexity. Okay, that's why programmer really need to concern about this particular problem because it already set, right? The main reason is that if memory location contain letters and numbers rather than zeros or ones, as everything is represented in the form of 0, 1, whether you are referring a particular letter, whether you are referring to a special character, whether you are referring to a particular number, everything computer is doing in the form of 0 and 1. Right? That's why we don't bother these things, right? But at least a few functionalities you should understand as a computer student. Okay. The next one, come to the secondary memory. I told you about there are two different types of memory. One is your main memory, another is your secondary memory. Okay, I told you main memory size is less, secondary memory size is big. You know that your hard disk size is either 512 GB or 1 TB or 2 TB or 4 TB. Where is your RAM size is 512 MB, 1 GB, 2 GB or 4 GB, or nowadays 8 GB is also coming, right? And you can expand it also, there is no problem. So main memory stores instructions and data while the program is running. Suppose I want to run a C program, at that time what happened? The program is need to load into the main memory and the instructions and data should be available. Okay. If both instruction data is available, then the program can be run in the main memory, right? Suppose you are not supplying the data, then the program will not be executed. Like I told you, suppose in a calculator, you want to add two numbers. So you have to provide the two number, right? that is 2 or 3 or something like that. If you provide the number, the calculator is going to process as per the instruction, right? Coming to the secondary memory is used for storage, right? It stores the instruction and data between two different sessions. Suppose you are executing some program that is there in the main memory. Once execution is over, it will come to the secondary memory, right? So secondary memory, we are keeping the data so that for the long-term use or after a couple of years or after a couple of months or after a couple of time, what we can do, we can access the data. That's why secondary memory is used. A file stores data or instructions in the secondary memory. Like movie, while watching, we are downloading the movie, we are keeping in the hard disk, right? We are writing a lot of programs, and these programs we are finally saved in the secondary memory, like our hard disks, right? And whenever it is required, we are accessing from the hard disks, right? We are at that time it is moving from the secondary memory to the main memory so that the program can be executed or program can be run through the processor system, right? Now, if you see a couple of secondary memories are there, which you may have seen, right? A computer might have any of these type of secondary memory. One is our hard disk. So you will have your laptop and desktop. Now you are using to view this, to see this particular lecture. This hard disk size is nowadays it is coming in the form of TB, but earlier it is in the form of GB, right? And it is a very high space. This is a GB is a very big one. TB is a big space, right? 1024 GB is equal to 1 TB. That much data you can store. Okay, one movie is generally 1 GB, right? Or some MB also one movie is coming, right? So you can store couple of movies, couple of files, couple of data, couple of PDF files, anything into the hard disk, right? Because its size is very high, right? But in comparison to other things, hard disk is faster, right? But if you compare with primary memory is always faster than the secondary memory. So generally, hard disk is fixed in our computer system. Whenever we are purchasing our system, it is already there in our system. It is already fixed. Normally, nobody is removing the hard disk. Only in case of there is a crash in the hard disk, then we are removing the hard disk and we are replacing it with another hard disk, right? But generally, system has its inbuilt hard disk, so no need to remove that hard disk, right? But nowadays, in order to support a high amount of storage, we have external hard disks. External hard disks are coming in 2 TB, 4 TB, so that you can use as a plugin to your system through the USB interface, and at any point of time you can remove it, at any point of time you can attach it, right? It is the first type of secondary memory. Coming to the second one, that is your floppy disk. You may have seen your childhood. In our time, we are using the floppy disk, but the size is only 1.44 MB, right? Very small, very small, right? Whenever we are taking our passport size photo, at that time in our our case, we are using this floppy disk to store that information, right? And there is a read-write head is also there in the floppy disk, right? So the size is very small. Nowadays, it is not used, and it is also quite slow in comparison to the hard disk, right? But the only thing is that you can attach to a computer system or you can remove from a computer system at any point of time. Generally, in the desktop system, there is a floppy disk drive, but nowadays, as it is not that much popular, it is not used, right? And you can share the data, you can copy the data from one computer system, then you can copy the data to the floppy disk, you can remove the floppy disk from one computer system, and you can insert into another computer system in which you can copy the files whatever available in the floppy disk, right? Now, after floppy disk, we have compact disk, that is we call as your CD. Maybe in childhood, whenever you are watching movies, we are going to the one CD one of place and we are taking the CD. And by looking the CD, we have a CD player. In CD player, we are watching the movie. But nowadays, these things are not used, right? And the size of the CD is 700 MB, which is quite high in comparison to floppy disk. But again, the problem is that the 80 minutes, the maximum time if you store a particular video, then the maximum length of the video is 80 minutes in the compact disk, right? So it is slower than your hard disk, right? And compact disk is easily shared with other computer systems. You can insert into one computer system. Again, you can write something into the CD, and you can again remove and insert in another computer system to do a particular work, right? And after sometimes the compact disk is also available in the read-write form, just like our pen drive, right? We are keeping the data. Sometimes if data is not required, then we are removing the data, right? This process you can do as many of times as possible. That's why this compact disk can be read-only or it may be rewritable. That we read as RW, right? Read-writable. But generally, early days, you are purchasing the blank CD and you are writing a few things, maybe a file, you are copying into that disk. Once it is burned, then you cannot add the data in the later stage, in the read-only case, right? But in rewritable, you can remove, add, and burn these things many number of times, right? That is the compact disk. After that, DVD came into picture. The DVD size is 4.7 GB, right? Where you can store multiple movies. Or if you want to install a particular software whose size is very high, like in higher semester, you are going to learn that is called as MATLAB, right? This MATLAB is used by engineering students, not limited to computer science, but mechanical people, electrical, civil, every people are using the MATLAB system. So if you go for this MATLAB, the MATLAB software size is 10 GB something, or more than that, based upon the package, okay, or based upon the tools you require for your application. So in that case, what we are doing in early days, we are writing this software into two different CDs, DVDs, or three different DVDs, right? There a DVD will come into picture. But nowadays you have pen drive, so these things are not that much used. Next, in order to access the memory, right? Memory access can be done in a sequential one. Sequential one means, suppose in your street, right? There are 10 houses are there, right? Each and every house having a particular number, right? So 10 houses are there, assume that 0 to 10. Okay, 0 to 9, you can say 0 to 9 is there, 10 houses are there. So I will tell you that you have to locate a particular house, okay, where you do not know that what is the house number of the first house, second house, third house, fourth house, fifth house, sixth house, so on up to ninth house, right? Starting from 0th house to ninth house, you do not know the house number. So you may tell, you will go to the first house, in front of the house there is a number, you are checking that number with the number what you want to search, right? And you are not getting. Then you are going in the second house, go to the third house, fourth house, fifth house, sixth house. At last, in the ninth house, you will find a solution, because I told you that in this street that person is staying, so you have to find his house, right? So that type of SS is called as a sequential SS. Sequential SS means you will start from the first position, you will move to the second position, third position, fourth position, up to the last position in order to locate a particular thing. Okay. So the data is generally found by searching through items first, right? I am checking the address of the first house, second house, third house. At last, I will definitely reach to that particular house. Maybe in the last house is in the my search list, right? So generally, the sequential process is done in the secondary manner. But another solution is there. Sometimes we are using random access. Okay, like you know that RAM, that is random access memory, is here the computer can directly access any memory location. Suppose I am aware that the house is located here, then I can directly go without going for a sequential search. Sequential means you have to go in a particular order, right? But random access means you can locate the house, okay, by following any order. Apart from the sequential, all the orders are random. Like I'll tell you, each and every house has a number. Let's say now 101, 102. If they are sequential, then you can easily say that if it is 101, then the fourth house is 104. That way you can locate a particular house and can access the memory, right? Now you see the memory hierarchy. I'm not going to tell all the details because many things we have discussed. Other things you can explore also. Memory is of two types. One is your primary memory and another is your secondary memory, right? And primary memory, you have read-only memory. Read-only memory means already something is written, you can only read, right? Like I'll share a PDF file with you. Okay, let us assume that you do not have PDF editor. So you can only read whatever I have said. That is called your read-only memory. And this is random access memory, what we discussed now. And random access memory is of two types. One is static random access memory, and another is dynamic random access memory. So you find the difference. Why it is called static and dynamic? Okay, because it will
Computer
divert,
programming classes.
because it will divert that main topic, right? So you can find the difference between static and dynamic RAM. Similarly, ROM is also various type. One is called as programmable read-only memory, and this ROM and PROM, right? They are, you can write once, but after that you cannot erase it, right? PROM case also programmable read-only memory. Once you have programmed, you cannot erase it, right? Like CD case, earlier CD case, whenever you are writing okay, into the CD, even if it is 700 MB space, rest 699 MB is completely wasted, right? So in order to write something into the ROM, we have erasable programmable read-only memory or electrically erasable programmable read-only memory. So these cases you can write multiple times, but generally ROM is written once or it is already written in the company and we are following that, right? So you can explore the difference between these things in the computer fundamental books. Coming to the secondary memory, what we discussed, hard disk drive, floppy disk drive, CD or DVD or pen drive are coming under the secondary memory. Sometimes pen drives and other devices like one pen drive is called as our flash devices. Flash devices or flash memory. Okay, so you can explore this thing. Now come to the processor, right? Each and every computer has a processor. So you go to your My Computer icon, in My Computer or computer icon. In My Computer icon, you right click, then there is a properties is there, right? And you click the properties, you will see what processor your computer system has, right? Whether it is i3 processor or 4 to dual processor or dual core processor, i5 or i7 processor, that you can look at. And typically we call the processor as CPU, that stands for Central Processing Unit. Why central? Because all the processing works are done by CPU, okay? And input, output, everything is connected to the CPU. So it is act like a centralized unit to provide services to various units. That's why it is called a Central Processing Unit. And CPU follows the program instructions. Suppose you have written a particular program, like I told you in the first class, a robot want to move from the source to the destination. In order to start from a source to reach to the destination, you have to follow a set of steps. That steps you have written in a particular program. Based upon that instruction, the robot is moving from one location to another location. So CPU is similarly following one by one instructions. First instruction, second instruction, third instruction. Whatever you have written in a particular program, that is the CPU is going to execute those instructions. Generally, if you see the capabilities of CPU include, it can do add operations, it can do subtract operations, it can do multiply operation, divide operation, it can move the data from one location to another location. Like you have C drive, D drive, E drive, F drive. So you can also exchange the data from between the two different drive, or you can move the data from one drive to another drive. These are the instructions followed by the processor, right? Generally, there is a arithmetic logic unit, that is ALU. This arithmetic logic unit is responsible for these operations. That is addition operation, subtraction operation, multiplication operation, and divide operation. Now coming to the computer software, I already told you software is of two types. One is your system software, another is called as your application software. System software is compulsory one, that is mandatory to run in the to run a computer system. But our secondary, that is your application software is optional. But application software is installed, you will get a better flexibility. For that, it is required. So operating system is one very important software, which is a system software, which allow us to communicate with the computer. Okay. So SSD is coming under our secondary memory, right? These all are coming under secondary memory. So operating systems allow us to communicate with the computer system. So you may have a Windows operating system. Somebody may have Linux operating system or Ubuntu, right? Linux operating system, some may have Mac operating system. Like there are a lot of operating systems are there, which is required to run a particular computer system. Okay, and each and every component communicate with your operating system to complete a particular task, and it is the application software, right? And operating system is also a software, means it is a set of programs. We have already seen in the very beginning classes that a set of programs with documentations, you can call it as a software, right? And operating system is allocating the computer resources as well. For example, you want to carry out a particular work, right? Suppose you want to carry out 2 plus 3 operation. This 2 plus 3 operation will be done by arithmetic logic unit. So what it is doing? So whenever you are submitting this to the processor, processor is going to add these two numbers in order to find the resultant number, that is 5, right? Like there are a lot of works are there which require computer resources. Computer resources means processor is a resources. Sometimes input device is also a resources. You want to print a particular file, that is also a resources. So allocating the resources to the program, right, or the instructions is the responsibility of operating system. Generally, operating system is also interfacing between the user and computer hardware. Like your computer system is having an operating system. One side your computer hardware is there, another side the person is present or we are present. So how we are interacting with computer hardware? Through the operating system. Okay, and it also responds to the user request to run other program. Right? We respond the user request to run other program. User can make request. Based upon the user request, it is running the program. Okay? So at a time it is following some instructions. Based upon that, it is doing. So common operating system, we have seen Unix operating system is there every days. Nowadays also we have Unix operating system. Generally, many industries they are using Unix operating system, Linux operating system. Our railway reservation system is coming under the DOS operating system, Windows operating system, Macintosh operating system, or virtual memory system, BMS or Open BMS is also available. These are the operating systems. Based upon the usage, many industries are using different operating system. But very widely, we are using either Unix or Linux or Windows operating system. DOS is now not used, but while we are studying, we are studying that at that time DOS is also there, right? But it is having limited functionality. Now come to the computer input, right? In the computer input consists of two things. One is program, another is data. For an example, you want to add two numbers. Just you go to a calculator. In the calculator, the numeric keys are there. So you are pressing 2, so it is displaying 2. You are pressing plus, so it is showing plus. You are pressing 3, so it is showing 3. So this 2 and 3 is nothing but your data, right? And this plus is nothing but the addition between two numbers. Addition of two numbers, right? Together, and you are generating the result. So computer needs both things, a program. Suppose I have written a program for addition of two numbers, or I have written a program to print a particular statement. And in order to run this particular program, it is asking some data. right? For example, I want to, if I want to do addition of two number, for that I have written a program and I am supplying 2 and 3 as a data, right? We are providing program and we are also providing the data to the computer. So computer CPU is going to execute this program, data will be supplied. So once the data is supplied, then you will get an output. So two things are required. One is program. Program is nothing but a set of instructions. Data is nothing but your values, right? Like I will tell you addition of three numbers, then you will provide three numbers. Addition of n numbers. So that you have to provide as a data to the computer, and you have to write a program which can do addition operation, multiplication operation, subtraction operation, division operation, modulus operation, any operation that you have to write in the form of code, okay, or instructions, right? Both things you have to provide to the computer so that computer can generate the output. Now there are many high level languages are there, starting from C. Early days C is there. Early days there is a language is there that is called as BCPL. That is called as Basic Combined Programming Language. So first letter of B, the very first language come into market, that is called as B language. But B language had so many shortcomings, which is so that based upon the second letter of BCPL, C language is there, right? C language was developed, which is an extension of your B language, right? Basically, B language, other languages are also support given some functions to the C, but most credit goes to our B language. So based upon the second letter of BCPL, we have written C, right? Similarly, after C, we have added object-oriented, right? Object concept is not there in C, so we call it a C++, right? Or C with classes is called as C++ in early days, right? And you can, with respect to each and every language, I request you to search who is the father of each and every language. Like I mentioned here, the father of C is Dennis Ritchie, and the father of C++. Other language, you find who is the father of each and every language. After that, lot of functionalities are added in the Java. Supports, right? Suppose you need some util package or some record, some specific package for a particular program, that can be done by Java, right? So, for example, you want to do a particular work, right? That can be done very easily if you add a particular package, right? Like you know that simply I can tell you that Netflix, you are watching a movie, right? So normal user cannot see the Netflix all the movies, right? Some movies are free, some movies are not free, or some trial users they are free, right? Trial version kind of 30 days or 20 days it is free, but you are getting the subscription. If you are getting the subscription means what? You can view their content. So you are subscribing their package, right? Similarly, the libraries and packages are added in the Java, right? So that the programming is much more flexible in comparison to C and C++. And many advanced concepts like threading, you will not understand now, but these things are added in the Java, which makes Java as a very popular language, and it is also called as fully object-oriented programming language. Similarly, early days Pascal is there. The full form of Pascal is Preservation and Storage Center for Academic Libraries, and it was developed by Nicholas Wood, who is the father of Pascal. Later point of time, Visual Basic is there, and each and every language, a lot of versions are also there, right? For Visual Basic 1.0, Visual Basic 2.0, like that, so many versions are there. Visual Basic 410, that is formula translation, extraction and report language, PHP, that is hypertext preprocessor, LISP, that is list processing. So these languages are called as your high level understood by computer programming, right? But computer did not understand these languages. These languages gives a flexibility to convert everything into the 0 and 1 format, so that computer will understand what you are writing in a particular programming language, right? That's why a compiler is required, right? You may understand this language as a programmer, but computer will not understand, right? In order to make the computer understand this particular language, we require a translator or compiler or interpreter. I am coming to that particular topic later, but you require a translator who can convert your language to computer language, right? Similarly, you can see other languages like Scheme, Ada, C has nowadays people are using Python, right? Python is also very popular language and it is widely accepted in various community, right? People are accepting Python in industries also. So these high level languages, what these high level languages are designed in such a manner that whatever keyword or whatever words we are using in our real life, such words should be there. For example, generally, if you take a printout, then what you are saying? Print, right? So their command is like print. Okay. So suppose you want to take something as input, file input. Then there may be a function called fopen or open, right? So whatever words we are using in day-to-day life, high-level languages are using that word to program that particular thing, so that user will not feel any kind of difficulties on remembering this word. Like I will tell XYZ is used for printing, then that is of no meaning, right? But if I tell print or print F or C in, then you will say yes, indicates that it is an input. So these high level languages resemble your human languages. Based upon the human languages, it is generated. Many peoples also, many languages are supported our prepositions and everything, right? So that people can understand a particular language. They are designed to be easy to read and write. The main thing is that you can easily read and you can easily write the codes as well, right? If you give difficult word, then it is very difficult to remember these words, right? And use more complicated instruction than the CPU can follow. There are a lot of instructions are there, right? Like if you go for C, C++, Java, any language you refer, there are a lot of your instructions are there, right? With respect to data type, with respect to variables, so many things are there, right? That is a complicated instructions are there. And these high level languages must be translated to what? The low level language. Low level language means your 0 and 1. If you convert your language, whatever you are writing code in high languages, if it is converted to 0 and 1, then the CPU can understand it and then execute your program. So finally, everything is 0 and 1, right? High level language need to convert to 0 and 1 through a translator so that CPU can understand what the user is writing into a particular programming language, right? Now you can see there is a low level language. So in assembly language, in between you have assembly language command. For example, I have written an assembly language code that is called as add xyz. What is add? As the name suggests, add means addition. Okay, xyz meaning that you have three things. One is x, another is y and z. In which what you will do, you have to add the value of y and z. Whatever value available in the z, you have to add and store in the location of x. Right? This is the not like this. Suppose I will take x, I will add x and y, I will keep in z. I will go in this order. That is also possible, right? In many languages are following left to right order, many languages are following right to left order. You may say x plus y is equal to, then x plus y is going to y plus z is equal to x. Both interpretations are correct. Many languages are also following it, right? So what is this XYZs? These XYZs are nothing but your registers, computer registers. Computer register is the highest processing power, or high speed processing can be done through the computer register. It is very fast memory, right? But computer register size is very less, like 8-bit or 16-bit or 32-bit, like that, right? Now, you see here, assembly language must be translated to machine language. Whenever you go for assembly language, any language you use, high level language or assembly language, the final one is what? Your 0 and 1. So, 1 0. Let's say, let us an example. For X, I am writing 1001. For Y, I am writing 1010. For Z, I am writing 101. In this way, you can write. Because computer can understand only 0 and 1. For add also you need to tell like this. If you want to go for X registers content, that also 0 1. Y registers content 0 1. Z register content 0 1. So irrespective of the language, finally you have to convert to 0 or 1 in order to understand that thing by a computer system or by a CPU, central processing unit. So CPU can follow only the machine language. That's why every commands, everything you have to convert to in the form of 0 and 1, right? Now come to the compiler. So there is two things I will tell you before going to this theory part. So suppose I do not know the Telugu, right? I do not know. Okay. So what I will tell? I will tell one of my friend Telugu. Suppose I know only English, right? So my friend know both English and Telugu, right? My friend requested me today we are going to watch Telugu movie in a Cineplex, right? Then I told my friend I do not know Telugu, how I will go with you. I will only see the picture. I will not see the content. So he told her, don't worry, I am going to tell you the content, right? So in what way he can tell me the content? He can tell me the content in two ways. The first way, he will tell me that you watch the movie. After the end of the movie, I will tell that what are the content covered in that movie. That is the entire part I am watching. Then he is telling the story, then I am relating the thing. Second option is after each and every statement, okay, then he will tell the actor or actress is telling this thing, so that I will understand and I will relate that thing at that particular point of time, right? If the entire thing you are doing at the same time, that is called as your compiler. If you are doing the line by line, one instruction, yeah, one dialogue is there that he is repeating me in English, it is converting from Telugu to English, then that is called as our interpreter, right? So compiler do all the instructions, it scans all the instructions, whatever error is there, that it is reporting at a time. But interpreter, when the first line is there, if there is an error in the first line, it will stop at the first line. Unless the first line is successfully completed, it will not go to the second line. Okay. So generally, compiler is used to convert the high level language. Level language means again your 0 and 1. So compiler input is nothing but your source code. Source code is nothing but whatever program, whether it is C, C++, Java, any language you are using, that program you have to give input to the compiler. After receiving this one, what compiler is doing? Compiler is converting high level language to the machine level language. Okay, and compiler generate the object code. Okay, like if you have written some file, let's say the file name is, I am writing one program, file name is writing, or I am writing only program dot a C++ is the extension. Okay, or you assume that some file I have written. So it is generating the same program's object file. Program name .o file. .o indicate the object file. This file it is generating. Understanding at this point. So object code is nothing but the translated version in machine language. The whatever high level language you have written in this file, it is converted to the machine language and stored in the object code, object file, so that computer can understand what is written in the object. Now you can see here what we are doing. There is a compiler. Instead of compiler, you can also use interpreter. Compiler is there in the computer, and you have written a in a particular computer. Then what happened? C++ program, generally the extension is .cpp. Like you know that document file or .docx, right? Or text file, the image file, the extension is .jpg, or you can say in the movie file, that is nothing but MP4. Similarly, C++ file, the extension. Okay, and there should be a compiler to compile or to execute the instructions that are given in a particular program. For that, you need a compiler. Both are there in a computer. So what the computer is going to do? It is receiving the high language, converting it to machine language program. So it is converting now to program. This is program, but once this program, that is nothing but the object code, you are supplying the data. I told you two things. Two things you are giving as input. One is program, another is data. But it is a two-step process. First we are giving program, then the data is given as input. Program is converted to your machine language program, and this data both are supplied to the computer so that the computer can generate the output. So this process we have to follow in a general compiling or running a simple C++ program, right? Now, some programs we use are already compiled. Many inbuilt functions are there that is already compiled. Many things are there in the computer that is already compiled. So if such a case is there, if it is already compiled means what? In this case, already compiled means what? Machine language program is available. Machine language program means what? The object code is available. So if object code is available, if you have compiled, already object code is there. That's why it is saying some program case we have already compiled, their object code is available. If object code is, then you can directly input that object code to the computer system. So you need not process. Like you can see here, you are generating the object program here. If object program is already there, we can directly supply object program here and data here so that the program, right? That's why what we are doing, these object code, that is nothing but your input or output routines, are directly provided to the computer system. Okay, your program is provided, but if the programs are already compiled, the object code is generated earlier, so object code is directly provided to the computer system. Then what is the responsibility of linker? The linker combines the object code of the program we write and object code of the pre-compiled routine. We are writing the C++ program. For C++ program, we have generated the object code, and there are some pre-compiled routines are there, either input routine or output routine, for which object code is already there. So it is combining both code into a single unit in order to produce the output. Okay, so that the machine language program, the CPU can run. So if you are getting everything, the program, data, and object code, everything is if you have, then the linker can link these things to execute the program. So the typical picture you can see here, I have written a C++ program that is in the high level language. Compiler is converting it to high level language to, that is nothing but generating the object code of this C++ program. After generating this object code, if some pre-routine is there, like input or output routine is there, object code is already there, or pre-compiled object code is there, that is also given as an input to the linker, so that language code is ready to run by a computer system. Okay, so this is the complete process we are following in order to prepare a C++ program to run in a computer processor, right? So you can see the first programmable computer was designed by Charles Babbage in 1822, but it is not completed in the Babbage's life period, although he is called as a father of computer, but the work is not completed by Babbage. So the first programmer, if you see, Ada Augusta King, okay, He was born in 1815 and died in 1852. He is called as the first programmer. Okay, and he is the colleague of Babbage, who has written the code in the first computer system. Right. So this is all for today. So these are the conclusion for the first two classes. You have to explore these things. That is, what are the main 5 components of computer you have to write, and list the data for a program that adds 2 number. You have to prepare a list of data to write a program. You have to prepare the data, not the program, because programming aspect we will discuss in further classes. Describe the work of compiler, and you see how compiler is different from interpreter. Then we have to define what is source code, what is object code, what is the difference between source code and object code, and why linker is coming into the picture. The last question is describe the purpose of the operating system. Without operating system, is it possible to run a computer system or not? That you explore, right? So these are the takeaway questions or the main concepts what we have covered in the first two classes.